things like that. And today's session will be focused on real robotics, and that is autonomous robot. So first, before starting this thing, let's talk about robots first. What picture we get if we think about robot? Not about any movie chapters and anything. I'm talking about in this current world, what are the things that what are the picture that comes to our mind first when the robot word crosses our mind first? That is, first of all, we talk about self-driving cars. Obviously, Google's Waymo is such a hot topic in this area. Apart from the Tesla's car, although it's an autopilot system, but Google's this Waymo is completely autonomous. That is still driving, although it's in test bench, but it's still driving in Palo Alto. We have space robots that is completely moving autonomously on Mars. That is Curiosity that you can see, and this wonderful robot from Boston Dynamics. So, talking about here today is not about something an undergraduate simple project that is LFR, RoboSoccer, anything like that. We are talking about real robots. And the main agenda of this whole session is to ask you one question. Can you, at this level, at this point of time, if I say, can you able to make a small prototype of this one, either this one or this robot, complex robot by yourself in a month? I just want to make this session more interactive, and I'm just raising a poll over here. And just for a fun, I just want to know, like, can you start this? Initiate building an autonomous robot, right? And okay, sorry for this small issue. So, hello, but am I audible and is everything okay?
Now it's okay.
Okay, okay. So I had created a poll. I hope you guys. Mm, okay. Anyways, I'm just creating another poll. Okay, so I have created a poll. You can guys see that. So in this question, what I'm trying to know, like at this point of time, at your current education level, whatever you are doing, in you are either in masters, undergraduate, 12th standard, what it is, I just want to know, can you guys think like what are the, can you create a roadmap in your mind? Like if I want to make a robot like Stanley, share the screen, sorry. If you're going to make a robot like Stanley, no, there's no Stanley, Google Vaymo or Curiosity or this one robot of Boston Dynamics Atlas, I just don't know, can you guys make this process? Like, do you have anything from the roadmap? Okay, so I do have robot, and I hope 50-50. Yeah, many of the players know, and some of the persons say that is very good thing for you guys. And I hope you might have or anything other platform, maybe Mathverse or any other thing. But today, in this, I'm going to tell you about a wonderful tool through which you can start this building. You can basically equip yourself with all the tools available to make or even start this building an autonomous robot. And all these robots, one thing is very common, that all of them is autonomous robots. And before diving further into this topic of ROS and what is robot operating system, why it is called robot operating, there's so many conundrums and questions about it. Let's first explore what we call an autonomous robot. What are those? Why this Curiosity, this Waymo, which is a self-driving car, this Curiosity, this yet another different robot. This is about this. Why all of them we call all of them an autonomous robot. So autonomous robot, this is a simple picture that explains like what are the functions, what are the different parts that is in autonomous robots. And I just want to make it easy. And since humans are also a wonderful autonomous robot, so I'm just replacing that picture with a human that wants to navigate from one point of place to another. And I just want to go through this every step that a human takes to move from one place to another place. First of all, human is equipped with so many senses. One of the common sensor is vision sensor. So from sensor, it first see what is it, and the question it asks, what do I see? I see I see so many cars. I can see the world around me. And from this world, it's very important. We call this process, we call this part perception. In this world, in this process, there are so many things that you can find. You can find the main task of AI, like deep learning, maybe object recognition, facial recognition, or in self-driving car that I have earlier discussed, you can say landmark recognition. They try to recognize, they try to understand the world. We are just mimicking whatever we do with ourselves when we try to navigate from one point to another point. We're just trying to mimic the same thing in an autonomous machine. So first part is from the senses, we try to understand the world. And in this, we feed mostly use artificial intelligence. We can't say basically artificial intelligence because artificial intelligence comprises so many things. We can say various parts of the AI, like deep learning, machine learning, SVMs, anything. Okay, and there from that, we first do one thing, that is localization. We try to localize in this moment, and then we try to build a map. It means the road should know how the world is it around it, how like where are the obstacles, where are the various features of the world. So we try to build a map, and then we try to localize in that map. Okay, and there's a very famous problem we say, that is SLAM, simultaneous localization mapping. There are so many algorithms that are present. We do which enables the robot to do this thing. Okay, so from vision sensor, we try to understand the world. And from there, if we can understand the world, we can know where I am from the localization, and where I want to go. That is a goal position. Now the second step is, what are the plans? What are the paths should we take? How my body arm should move? I need to do to reach my goal position. And that's the second, part of this whole autonomous robot comes, that is planning. And in it we get so many classical, you can say classical robotics application or algorithm, that's path planning or motion planning. Another one is behavior planning. Okay, just leave it at that. So behavior plan. So from the human's perspective, suppose I want to go from one place to another place. First, I did the perception part. I understand the world, and now I can understand or identify what are my goal points and what are my obstacles. Then I try to plan how I'm going to reach that goal. So I created a path in my mind. That is path planning. Then I thought, in order to execute that path, how I'm going to move my arms, move my legs, move my body parts, what will be my body structure in following that path. That is a motion plan. And then I think, suppose if I get any kind of obstacle, if a cat crosses it, if a lion comes in front of me, what I will do? I will switch to different mode. I will switch to a different mode, that is run from the lion, or not from the walking, I can switch to the running mode. That is, I'm deciding the behavior of my system. That is a behavior plan. I try to do all these things before reaching the goal. Before starting is planning to execute whatever I plan. I have to do all the things in my books before doing that. And that is the second part of this autonomous robot architecture, that is planning. Third, I have understood the whole, I have planned everything. Now I want to execute whatever we plan. And there comes and wonderful another domain of robotics, that is control. And everybody might have heard, like, so in this session, in this autonomous robot thing also, I was just want to clarify one more thing. Like, robotics is, you can say, amalgam of everything. Everybody say robotics is a mixture of mechanical engineering, electrical engineering, computer science, electronics. But why it is so? Because all the different parts that we can see over here. Without computer science, we cannot do AI things, because we need to code that. Okay. Without a simple mathematics background or anything else, we cannot do planning. Without the concept of electrical engineering, that is a control theory, basic or electronics engineering, we cannot build a controller. And to build that controller without the electronics components, electrical and electronics components, we cannot do build basically implement these algorithms on a board. And without the structure, the mechanical structure of our body, we cannot build. If even we build the code stack, we cannot create autonomous robot. That's why we need mechanical, electrical, electronics, the core branch of robotics. So moving back to what we have discussed, what we were discussing earlier. So after planning, after we try to implement some controllers, and you might have heard of many controllers like PID, proportional integration derivative. There are MPC, model predictive control. There is IQR. There's so many controllers that is present that you can use in that. Okay, and so localization discuss. So going through all this process, perception, planning, control, we execute a command, and then we move one step, then second step, then third step, and then we finally reach the goal. And that is the main thing. If I remove this picture, that is the main idea behind an autonomous robot. An autonomous robot is equipped with so many sensors. Just let me start this again. Okay, so as you can see, an autonomous robot is equipped with all the sensors. It's not like we have to give so many sensors. There's a laser LiDAR sensor that can give you distance data. We can do so many things with LiDAR sensor. These are the wheels, and wheels are run by motor and motor equipped encoders, which help it to localize itself. I think here is a sonar sensor, maybe to give the obstacle distance with lesser proximity, and maybe it has a GPS. So what I'm trying to do, like we need to give an equip an autonomous robot with so many sensors. We need to deal with these sensors, and we need to do all these steps in order to make an autonomous robot. So if you guys any doubt till now in autonomous robots, so kindly tell me. I'll just go around the chat and check. Okay, I guess I'm moving ahead then. Okay, now next question is, okay, now I understood what are the parts that is required in autonomous robot. I want to do real robotics. I want to make an autonomous robot because I've seen so many movies like Terminator and so many X Machine and everything in which they have made an autonomous robot. I want to do that. So let's break this part, break this whole complex problem into one simple example. Suppose I have a sensor. This is a depth camera from Z. It's a very wonderful sensor. I have this camera and I want to get its sensor data onto a computer. And there's a Raspberry Pi, a simple onboard computer that will be equipped on your robot. So I can make a robot, a small human-like robot. Okay, it's not an alien, guys, but let's bear with me on this. Okay, so we have a robot which has this wonderful computer on it, and I want to get the sensor data on it. Now, how I'm going to do that? How I'm going to solve this simple process? First of all, I have to understand the electronics of this thing, how this sensor is sending sensor data. There might be some protocols, maybe SPI, maybe UART. There's so many protocols that you need to understand, like before getting the data. So first of all, you need to write the first part is the writer driver for it. In many cases, you get the driver pre-built with the software. When you buy a sensor, we get the driver, but to extract the data with it, you need to write a one code to get the data. In this, we need to understand the protocols of in which how it's sending data. There might be some parity big. There are so many things that we need to check, because if the data is coming serially in form of 0 1 0 1 0 1, you need to understand like till which length, whether it is a 16-bit data, 8-bit data, how much parity in it, where the checksum bits, and you need to check everything with it before getting data. So extraction of data is very important. You need to do it by yourself, and it's a very tedious task to do it. Then it's not actually like possible, like you are using sensor data only for one thing. You are using the sensor data only for the facial recognition. Suppose that in one code you're actually doing the facial recognition, and in another code you want to do object recognition. So you need to pass this sensor data to two different codes at a time. How we're going to do that? How you're going to? So why I'm trying to say, suppose in this code you have directly access the camera and you're getting the data. Then you cannot do this. You cannot access the same thing in another code, because it will say device is already used. So you have to make another code that will get this data, and through some protocols it will transport those data back to these two codes. You need to do that, and you need to write a third code. You can say transport code, and then your code itself, you need to decrypt that whatever the data it's sending, and you need to use that. So you can understand, although the slides look very messy, and it is very like it's basically resembles the task that you're going to do. It will be very messy. It will be very tough. So let me clear this yet again. Okay. So you're going to solve this issue. How is there any tool? Is there any problem? Whatever it is there any solution of this difficult problem? Okay, so I just have one request to everybody. If you have any questions throughout the session, you can unmute yourself, and then you can talk to me. Okay, because I'm not able to see the chat and everything over here, so I have to do that. Anyways, so what is the solution? How we can solve this issue? Because suppose it's a matter of only one sensor. We have so many sensors on an autonomous robot. This is not the only one sensor. We have IMU, we have uh, we have wheel encoder, we have GPS, we have lidar sensor. We have so many different sensors that will be equipped on a simple autonomous robot. And how you're going to deal with this problem, and the solution of this problem is what the today's topic of this session is: robot operating system, that is ROS. And it was started actually in Stanford's Artificial Intelligence Lab. From there, it moved to Philo Garage, and now from 2013, it's been managed and updated. Everything going on is going to be done in Open Source Robotics Foundation, OSRF. Okay, so it was started with the same problem that I have discussed. The standard Stanford AI Labs, the developers, they first thought, why we are developing, basically reinventing the wheel again, because you're not the only person that have used this Z camera, and you're not the only person that has been that has faced this too. And then you have to reinvent the same thing for another sensor, for lidar sensor, for sonar sensor, for so many sensor. Why do we need that? Why can't we have a standard framework that will enable this thing, that will make this process very seamless? And on the same very concept, the ROS was developed, Stanford AI lab, and then it was moved ahead to different foundations. But the main idea was to solve this issue and to provide a framework. Because of this thing, it has become so popular in very short span of time. And I can assure that if you are currently using MATLAB or any other, there is the Microsoft's robotic software platform also, you will not find this thing like more robust, more efficient than ROS. You're going to love this thing. Okay. So moving ahead about ROS, let me discuss you what ROS is. What you might have think like, just first answer the question, what is ROS? But there are two, three things that I want to address, which is present in the name itself of this thing, ROS. That is robot operating system. The name itself is robot operating system, and if it's an operating system, why it is not an operating system? We do not call it an operating system because it runs on top of the operating system. We need a Linux machine. We need a Linux machine to run ROS. We need actually Ubuntu environment, Ubuntu 16, 14, 18, 20 also. And nowadays ROS 2 is in market and it can be installed on Windows also, but we'll be focusing on ROS 1, and it will be and we'll be using Linux system. So first of all, it's not an operating system, it runs on top of an operating system. But why the name is robot operating system? Why we call, if it's not operating system, why this? Why do we want to call it, name it an operating system? Why do we use operating system in this name? Because like an operating system, it provides everything. First of all, it provides an interface to talk with the hardware. We have sensor, we have a machine on the board. It provides the interface to talk to the sensor, to machine. Hardware software interaction, uh, uh, it actually enables it. And say likewise in another, like all the, it handles all the communication protocol, everything, like a robot, like an operating system does, and whatever required, it does everything. For in simple words, I can say that whatever an OS does for a computer, it does for a robot. And that is why we call an operating system. Yet again, it's not an operating system. Another thing is, if it's not an operating system, it will be in a programming language. No, it's not. It is actually a framework. In simple words, I can say it's actually a framework on which you can use different languages. You can use C++, you can use Python, you can use Java. It utilizes these languages to build your course, to do everything. Okay. Apart from it, it's not an IDE also. It's not an integrated development environment. It's basically a framework. It's not, and even though it doesn't, it's not only a set of libraries. It's not even that. Okay. So what exactly is ROS? I've discussed it is an operating system, but yet again, it's not an operating system. It's not a programming language you can use. So different programming language, and mostly people prefer with ROS. It's not an IDE. It's a framework that provides everything, that provides a platform for a robot to interact with a sensor seamlessly, to implement so many algorithms of planning, maybe perception, localization by itself. It provides that. It handles what we have discussed earlier, this communication problem. It handles it very, very seamlessly. Okay. And I just want to take a short break to discuss, because I think it's a very important to talk about. Like, do you have any other doubts on what is ROS and what ROS is not? Because so many persons might have like, I feel I have taken so many sessions, so I get so many questions. Like after the session, like, say you have told me this thing, whether this is ROS, and you elaborate more on ROS. So I just want to know, do you guys any questions on it? Just type yes and no in the chat. Okay. Anyways, so just moving ahead. So we have discussed the history of ROS, but ROS is not. Now, okay, there was some animation here. Anyways, so second question is, why do we need ROS? First is, it's free and open source. It can be used for research purpose. You don't have to pay anything for license. Unlike MathWorks, you need to pay, or you need to get a hacked version. You don't have to do that. It's free and open source, and that is the most, you can say, uh, the important part of this course. The most important thing that helped to flourish and be popular in very short duration time. Because with free and source, you get a wide community. On an open source project, like you say, for drones, we have a Pixoft and Arduino Pilot. It's an open source platform. It's a very popular, everybody use it, and you have a very wide community base. And because of that, you get so many updates very easily. You get so many issues. If you face any kind of issue while dealing with ROS, you can get answers very easily because of the wide community. Second thing is, it's a distributed computation, and let me elaborate it more on with this picture. As you can see, we have a robot. It's an industrial arm. It's a very famous one, KUKA robot, that we call KUKA industrial arm, and it has a computer. Basically, this robot has a set of actuators over here, over here, over here, over here, even over here, to give different motions of this thing. We have this robot. We have a computer. Now, suppose we want to do something in which we need more computational power, and we need to add 2 3 computers on it, or we need to monitor whatever happens on this computer, on this robot's computer, to a different computer, maybe on this monitor, on this, or maybe on different computers over network. So can ROS enable this thing? Yes, it can. And that is one of the core feature of ROS. It has a distributed computation, which means you can distribute this computing cost, everything on different computers. You can connect 2 different computers. Suppose it's a computer 1 and it's a computer 2. You can connect 2 different computers for one task. Okay, you can do that very, very easy, and ROS facilitates this thing seamlessly. You don't have to worry about this thing. Another thing is, one of the key advantage of, yet again, this free and open source, because of free open source, that you can use softwares very, very easily. And what I'm talking about, you can use a pre-built software. There are so many pre-existing software that is already present on ROS framework, that is SLAM, or maybe AMCL, that is Advanced Monte Carlo Localization, that is help for that basically use a particle filter to localize a robot. And the implementation of this, the beautiness of this thing is the implementation of this algorithm is like you don't have to configure it for two different things. Suppose you have two different robots, you don't have to do differently for both of them. Implementation will be the same on on the different platforms. You don't have to worry about that. And that is the beauty of the ROS. It has standardized this framework, this platform. If you want to implement SAM, you have to do the same thing, go to the same process on suppose on a drone. Let me do that. On a drone, if you want to do SLAM on a drone, you want to make it autonomous, you can do that. Or if you have a mobile robot, you want to do SLAM on it, you can do that. And the implementation part on both of these platforms will be the same. You don't have to worry about that. Apart from being by providing an standard implementation, what is more what I am very fond of this thing is like, even though you don't have knowledge of SLAM, even though you don't know what are the theory behind SLAM, we just know that it gives me a map and it gives me it can localize itself in the map. That is the name of this algorithm itself: simultaneous localization and mapping. I think I have discussed it earlier. So you don't have to go through or delve into the theories of this algorithm. You don't have to go to the mathematics. You don't have to do anything of that. There are so many different packages also available. Like suppose you don't have to, suppose you want to do sensor fusion, okay, and you don't know anything about Kalman filter or extended Kalman filter. Okay, you don't know anything about that. Yet again, you can implement that using ROS. And that's opens so many doors for a student that is still in undergraduate. Because if you are in undergraduate, if you're doing your bachelor's, maybe in Bachelor of Technology, Bachelor of Science, and you have so many interest in robotics and you want to create an autonomous robot, and you don't want to go into the mathematics and all, you don't have to do things from scratch, and you just want to make a prototype so that you can get inspiration from it. And even though making a prototype with it, you can help you understand so many things with the existing algorithm that I've discussed. You just want to start something, you just want to do things. Then at that point in time, it will help you a lot, because you don't have to worry about all those things. You just have to go through the implementation part. You can implement it, it will work, and then you can understand. Then you can write your own code. Then you can do everything, and that's a very beautiful thing. Apart from it, you don't have to worry about like whether the code is efficient, whether it's your computer can handle the computation part. No, it will be stable and well debugged code, because it is presented on ROS framework, and that is free and open source. And because of being free and open source, it is widely, it is it has been maintained very well. Another point is it enables you for rapid testing. And by rapid testing, what I mean, suppose you are in industry, or you are writing a paper on some robotics and you want to do some experimental work, and you want to test it on you want to get the experimental results very fast, and you want to make a prototype very fast. And ROS, if you're going to use ROS, it helps you very easily. Like it helps you, enables that rapid testing. And how it's going to do that? First, I have discussed that a robot has sensors. So in order to do the rapid testing, you need to have a pre-existing, all the things that I've discussed, you need to have that to communicate with the sensors. And ROS facilitates that. It has wide variety of support, a wide variety of supports of sensors. There's a camera that, which I have discussed earlier. It's dynamic servo motor, which is also being used in industry quite often. And this one is a very famous LiDAR. So if you go and search about LiDAR, this company, Velodyne, will become first. And everybody you can say, even on the Google Waymo's car, you will get a Velodyne LiDAR sensor. It actually uses LiDAR sensor. And you don't have to go through the communication protocol with Velodyne or all these sensors, whatever it is. You don't have to go that. If you are going to use ROS, you will get all the codes pre-built, and you can start working using sensors, start working by getting the data. Because if you're going to use sensors, you want to do something with the data that you're getting. You might have your own algorithms. Suppose you want to fuse the data of this lidar sensor and the camera data. You want to do that. Okay. So, and you just worry about the data. You just need give it something that can provide me the data in this format. You can do that, and that's why it enhances the rapid testing. Second point is, you have sensors, you have everything, you have so many support of pre-existing. These are basically robotic software hardware platform. This is a robot now on which you can implement pre-built hardware platforms in which you can implement code. On now robot, you can actually implement so many motion planning algorithms, path planning algorithms, like a humanoid robot. And these are some differential wheel robot. This can be used for indoor navigation. This is the famous robot, the Turtlebot. So all of these robots are already present, and these robots have been used for research purposes. And if you need to interact with this robot, interact with the sense of robot seamlessly, you can use this ROS because it supports all this very easily. Apart from it, if you had got the communication, got the data, and you have everything, but it's not easy, it's not you can say it's not avoidable. Like you will get at the first run only, you can complete, you will get whatever you need. So suppose you want to do an object recognition. What I'm trying to say, if you work on a project, you cannot make the thing work for the first time itself. You need to debug your code. There will be some error, there will be something in your code, and you need something to find that error, because you cannot just wander your head into the piece of code and go through the line by line and rectify the error or get the find the error. You need to have certain tools, certain software that will help you to complete this thing. And that is where this ROS comes. ROS has so many visualizations, debugging, and even before, if you want to get a start with the real hardware, you can do the simulation also. It has very reliable visualizing, debugging, and simulation tools that you can use. And these things eventually will help you to test your code, test your build your product very fast. Another thing is, you don't have to be a simple programmer. Like, you don't have to be a C++ writer, you don't have to be a Python writer. If you are Python, you can use a Python code. In our project, that in so many robot which I have made and my team built, in which we have used both. We have one code is running by C++. We are doing all the controller part by C++, and we are doing, since the deep learning and AI is more on Python, so we are doing object recognition, facial recognition Python. You can run both of them on ROS platform. So it actually extends the capabilities. Like in MathWorks, in MATLAB, you need to know the MATLAB language only. Okay, or you need to have a basic understanding of C++. Okay, but on ROS, you can actually fuse two different languages, and that's basically beautify this C++, this ROS. Okay, and the last one is large community. I've discussed earlier, and it's so many. It is actually so many positive impact in helping the ROS grow and keep handling the repositories and updating ROS and everything. So before going to the future robotics, I just want to ask, like, do you have any questions, anybody, on ROS and why you need to ROS, or anything questions that you might ask regarding it? Or am I getting so fast? Like, am I speaking so fast so I can? Okay, then. I hope you're. So till now, I have discussed like why you need to take ROS. But before that, I should have discussed like why you need to come in robotics itself. why you need to basically come into this complex mess. Because for me, robotics requires so many skills. It's not a pool of only one skill. If you have one skill, if you know only programming, you cannot be here. If you know only control theory, you cannot be here. You can get a job, you can do anything, but you need to have few more other skills. Why do you need to come? Because of the fact it's a growing industry. You want to come. If it is a declining industry, you'll not come into this, because suppose you don't want to be a blacksmith, you don't want to be a carpenter, because that industry is very low, it's not growing, it's a very old industry. Okay, and apart from you guys are engineers, you want to get a challenging part. So that is why the future of robotics and this pandemic situation also helps us to understand the importance of robotics, because everybody talks about social distancing and nobody can touch anyone. So how are we going to solve this process? We are going to solve this with automation. We need robots. And actually, one of my colleague actually, he in Chennai, there's a company Robothoughts, and they have made a wonderful robot. They in the association with Chennai police, and it's an robot. They are actually building. They have built on ROS, I guess, and they are actually fusing the autonomous capability with it. But till now, they have a wonderful unmanned ground vehicle on which they have a camera, and it actually detects persons in from it and can get the distance between the person and warn them if they are not finding the social distancing. Apart from it, when the first pandemic situation occurs in China, there was a news that they are using robots to sanitize the city. They are not using any human force so that to curb this spread of virus. So these are, you can say, a current situation which through which we can understand the importance of robotics and what will the future robotics. And from the statistics also, the compound annual growth rate, that is CAGR of robotics is 25% from 2019 to 2024, and it's actually a market of $37.8 billion till now, and it's going to grow further. So it's a very big industry, and it's a common saying in here in India is there is no such market in, there is no such companies, there is no future of robotics in India. And I think that is a very big lie or a myth. You can say there are so many companies, so many wonderful companies that is working robotics, because one part of robotics is developing code, and India is, you can say, the Silicon Valley of this coding skills. We have so many programmers, we have so many developers over here, and there are so many companies that has been working on robotics, and especially in the field of autonomous robotics. There's a startup in Bangalore called Flux Auto that is working autonomous trucks, and there are another maybe Satyaj Robotics or something. There's so many startups also that are itself working on self-driving cars. So not only US, India is also, and so many startups over here also that are working on robotics and especially self-driving cars. Apart from it, we have drones industry. We have, like, although the drone industry in India is it's just on the starting phase, but we have so many promising startups in India. So many startups working on agricultures. So you might have heard recently the locust attack that happened in Rajasthan, and they used drones to crumb this issue. They use drones to spray the chemicals over the locust and to confine this issue. So there are many examples that India is going to be a leading industry. And from this graph itself, you can say the regional growth rate in the Asia sub-region, you can say India also is very high. Okay, so the robotics industry is promising. The future of robotics industry is promising. It's going to grow. You don't have to worry about, like, and apart from it, if you have 2-3 skills, is a very best industry for you. Okay, and there are many, you can say, major players in robotics is Tencent Corporation, Farm Corporation, Kuka, Kawasaki company. I don't want to. Okay, I have few companies in mind who are working on core robotics. That are the video that I sent shown you in the first slide of Boston Dynamics. Those are working humanoid robot. Even though they have built, you can say, four-pedal robot. We call it a four-legged robot, and that was adapted by. They call it Spot Mini. Kind of, they have mimicked the feature of dog, and that was adapted by Jeff Bezos. I think last year or last to last year. So these companies also, but you might have will not see the names of those companies over here. The reason is, I understand. I just have told you, like robotics industry in India is growing, even in Asia sub-region is growing, but surviving a robotics company is very tough. They are so, even though so many startups have a promising career ahead, they are doing a wonderful job. But apart from that, the failure rate of a robotic startup or company is high. Why is it so? Because it requires so many research and development, and it requires funding. It needs time. Suppose if investor invests in a company, so some people maybe wait for 5 years or 2 years or 3 years. They might have patience for that. But in robotics industry, you cannot say that. You cannot get a promising prototype. If you have very good vision, you cannot have a promising prototype in 2 3 years. You might require longer durations. Yet again, building a robotic prototype is not like belongs to a simple domain. And these are the reasons why robotics industry fails so much, but why those robotics industry that has a promising future, like Boston Dynamics, like Tesla, you can say, like Google's Waymo, Swing project also that is working on the drones, I guess. Why they have been not mentioned in the top 5 players? One thing you can see common in all these major players is that they make industrial robots. KUKA, which I have shown pictures earlier robot, a robotic arm, KUKA, Denso, Fanu. These companies are already basically in industrial robotics. And by industrial robotics, it means they have already a marketplace. They have a pre-built marketplace available in industry. The car manufacturing company, you want to automate your industry, you want to automate your inventory, you will get the robots from KUKA, you will get robots from Fanuc and Kawasaki Robotics. You will get that very easily because they have an existing profitable marketplace, and that is why. And these basically major players, I forgot to mention, is because of the profit share, how much they make, how much income they get. Because of that, these are the major players. Apart from, if we consider about the research and development, that is altogether different story. You will get different companies in different domains. For legged robots, you will get Boston Dynamics. For, you can say, for self-driving cars, you will get Uber or Google or Waymo. For drone delivery, you can get Amazon. You can get Google's X-Wings also. So many uh, different companies, and these famous which are basically on is basically because of the company or a profit which is made. So coming ahead to this ROS topic, like, okay, it has so many features, it has given me a platform, but question is, who will learn this? Who should learn ROS? And before coming over here, I just want to break in and get questions. I actually do this thing repeatedly, although you guys don't answer. It's just to understand like if you get any issues or not. Anyway, so who should learn ROS? The first option is very optimistic. You have to be a robotics enthusiast. You have that spark, you have to have that intention, or you have to that aim that you want to make an autonomous robot. I'm talking specifically about autonomous robots because if we're going to talk about simple LFR or simple remote controls robots, or some servo controls humanoids, a small robotic arm kind of say, that's not a use. That's not actually been required in this current industry. We have to move ahead and we have to focus our specifically on autonomous robot. And for that, a very optimistic, a very important character point that we need to have is you need to be a robotics enthusiast. Second thing that is very required for learning ROS, like you cannot actually use ROS to learn a language. You need to have a pre-existing basic programming skill. I'm not talking about you have to be an advanced developer or anything else. You need to be you need to have a basic programming skill, maybe of C++ or Python 2, because the latest version of ROS actually uses Python 3, but till now, till the ROS has different versions actually. So ROS has it started with basic ROS, and it has so many different versions: ROS Indigo, ROS Kinetic, ROS Melodic, and recently Neotic also launched. So you need to have a Python, and till ROS Melodic, ROS actually uses Python 2. So you can't use Python 3 with ROS. You need to do extra thing for debugging your code, for actually combining your code. Second thing, why you should or who should learn ROS? Who wants to build a strong foundational concepts to embrace the real robotics, because real robotics, I'm actually emphasizing on this thing because real robotics is very tough. I don't want to break your heart, because you might like it. Robotics actually industry seems very fascinating. It seems like you're doing a very great job, but it's very ugly, it's very tough. So in order to embrace the challenges of real robotics, you need to have a strong foundations. And to do that, ROS actually gives a perfect platform, a perfect framework to start your career in robotics. And if you want to build a strong foundation, you have to learn ROS, because if you're not going to learn ROS now, at certain point of time you have to do that, because every industry in robotics uses ROS in certain in actually different domains. And if you want to do research for purposes, you can use ROS because it facilitates the rapid testing, which we have discussed earlier. So in research, basically we need to get the experimental results fast, or if you have actually have your developed your algorithms and or develop the theory behind what is the algorithm, and you need to test that. You need to get the result fast so that you can publish a paper or you can debug your algorithm, whatever it is. So you need to do that. So for that, it provides a perfect framework for robotics research. So if you are into robotics research or any research related to robotics, if it uses something from robotics, you can actually learn ROS, or it will be very beneficial if you learn ROS. Second thing, you don't have to be a robotics researcher. Suppose you say for fun only, you just want to experience the advanced algorithm that has been already used. Suppose the algorithm that has been used in Google Farmers, the driving car, algorithm that has been used on the Curiosity rover that is on Mars. You want to experience that. You want to do it by yourself. You want to experience like how it has been done, how it is done. So for that also you can use ROS. Apart from it, you can use it for sensors extraction, for sensor data extraction, because there are so many packages that can give you extract the sensors data. And actually some of the companies, the Flux Auto, which I have told you earlier, they actually uses ROS for extracting the sensor data. They have so many sensors, and they don't want to go into the details of the protocols, and they don't want to go into write that. They just want to use ROS, use something to get the sensor data, and they use ROS for that. Even for that also you can use ROS, because if you can get a sensor data, most of your tasks has been already solved. Okay, now the last thing is why I'm presenting, why you need to learn from us. And before actually answering the question, I want to change this topic, and especially for ROS, I want to do that. Why not alone? Why you why you can do it by yourself? Why can't you, since it's an open source, since it's an free, there's so many, there will be so many support, and you'll get so many support from the its community. Why can't you learn it alone? Why can you self-study this thing out? The issue is ROS has a very steep learning curve. Why is it so? Because first of all, ROS actually runs on top of a Linux system. So you need to have a pre-existing knowledge of a Linux system, because on Linux system, the terminal is the core of everything. You need to know the basic commands of Linux, the basic commands, basic tools that is present on command line. You need to understand the architecture also. You need to have a pre-existing okay, so you need to have pre-existing knowledge of any C++ skills. But if you're going to do it alone, you have to do this thing first. You need to do it by yourself. And we here at TechHub will be providing you, will be assisting you throughout it. You don't have to worry about it. Apart from it, when you learn ROS, you'll get so many errors, because at the first step, actually, if you're not going to learn ROS, if you're going to do anything on Ubuntu system, on a Linux machine, eventually you're going, at some point of time, you're getting errors. And errors are so discouraging. Errors and warning messages are going to so discourage. And if you start learning ROS in the beginning only, you get so many errors, you get so many error messages or warning messages, you will get disheartened and you say, okay, whatever it is, I don't want to continue this further. But this thing is important. This thing is very important for robotics career. So we will be providing you a complete, throughout the session, we will be providing, assist you to learn this ROS, to flatten this steep curve of ROS. Second thing is, there are so many things you will find on ROS, and you will first wonder like from where you should start. You will not get a correct path to learn ROS. And due to this only, there's a possibility that you will lack the foundational understanding of ROS, and it's going to hurt so much, even though you have learned ROS and you have foundational misunderstanding. Uh, because I have known few persons which they actually, I don't know from where they learned it, some of my colleagues also, but still they get confused from the very basic concepts from it. They get confused what are the file system of ROS. They do not know like from where to install a package, what are the file directory. They don't know how the messages work and all. So it's a very positive, like you guys will be very prone to lack foundational understanding of ROS, which is very important. You will get so many errors. That will be very discouraging. Second thing, you'll be like running off of Linux system, and you need to be a programmer first. If you're going to join this course with us, first of all, we will clear this thing first. We will teach you basic commands. What are the basic? Because if you're going to learn Linux itself, there are so many things that you need to do, and the same thing will happen. Like you will wonder like from where you should start. So we know what are the sets of command that you require to throughout the course. Like we know what are the commands, Linux commands, what are the things you need to know before learning ROS on Linux, before going to do that. Second thing, we will have one session especially for the C++. If you are a programmer or already a programmer, you'll be having a revision on that. And apart from it, we will be having a session on C++, and so that you will not get any difficulties for learning or understanding the course of ROS. And third thing, we will be assisting you throughout the course, even after that, to decrypt, or you can say remove all these error messages and make your code working very easily. So these are the reasons that is basically the reason that you should not learn ROS, because it will be like it will be like you are flying an aeroplane and you just a car driver. The basically the resemblance and analog is the same over here. So we have actually this autonomous robotics with ROS course. It will be a 30 hours, and will be we have this thing on Tech Hub website. You can go there, and if you want to go into this wonderful world of robotics, and you want to have a perfect tool with you, you want to equip yourself with perfect tool and everything, you guys can check out this course, and even and you can register for it. Okay, wing drivers. So, just, so any questions if you guys have? Yeah. So any questions if you have guys have now, you can ask. Throughout the session you was long, but eventually. So let's get some questions, and I think it will be very fruitful for us also to interact a bit, and let's discuss on ROS. What we want to do. Okay, record the session. I think the session will already recorded, Lavanya. Yeah, so yeah, the session will be already recorded. I think it will be present on Tech Hub website, but Alka ma'am will be more, can give more information on that. And yeah, do you have any questions? So Vigneshwari is here, Abhishek Das, Siddharth, Chandan. Okay. All right then. Alka ma'am, if you are online, can you come up? Yeah, even you can ask
Hello.
any.
Um,
Yes, ma'am.
yes. Hi, Kashif. So, guys, if you have any questions, you can directly unmute yourself and ask from sir, or else you can drop your queries in chat box also.
Yeah, and not regarding this ROS only. You can ask anything regarding the robotics or related to what is existing technology that is present in industry. So we can discuss on that also, and it will help us. And we can also discuss how ROS is helping these industries.
I think there are no questions, Kashif, so we
Yeah.
can wind up the session.
Hello.
Yes,
So,
yes, yes,
Yeah.
yes.
so I'm here, and can we integrate artificial intelligence, machine learning to this ROS?
Yes, you can. Yes, you can. That's why I've told you about. That's why I told you in the perception part. Also, there you can. I've talked about AI features. Okay, so you can integrate that. That is very easy. You can do AI with ROS. You can do deep learning with ROS. You can do facial recognition. And the most important thing is, with ROS, what you can do, you don't have to go through and buy sensors. You can do in simulation itself. You can train your model in simulation. You can test it in simulation, and ROS has a very wonderful simulator that is Gazebo. So you can test that, and you don't have to, everything will be on your system up and running, and you don't have to do anything that. You can create a virtual world in the simulator, and you can test that. Suppose I will give you an example. Actually, it's a very common thing. You might you might get so many papers on it. There's so much research is going on robotics arm, because in industry what they are trying to do is increase this interaction between robot and human. Because nowadays if you see a robotic arm in, suppose in a car or factory or any of this, they do whatever it is there. They suppose they have to pick something and drop something, they do this in predefined path. And if a human by accident places his hand, it will not do anything. So nowadays many research is happening in which they are fusing this AI and machine learning part, in which they have equipped that robotic arm with sensor. So if a human's hand or anything will go in between its part, it will change its course and react to it, likewise react to it, this thing. So yes, you can fuse AI with it, and so many people is doing with it. So you don't
Okay.
have to worry. Any, yeah.
Sir,
Okay, Lavan.
in underground robotics, means underground robots can be
You're talking
designed
about under
underwater.
vehicle,
Underwater.
underwater. Yeah,
So it is we can simulate using ROS underwater.
yeah. Yes. They are actually, if you want to check that, check Ardu pilots and on ROS. If you'll go through the Ardu pilot website, there's so many different models. Actually, do you know about this Ardu pilot? There's a flight controller unit, and
Yes,
that has been, yeah,
yes, sir. I have made.
yes. I think you might have. Yeah, so if you are underwater into this thing or drones, you might have heard this thing, and that unit can be used for drones. Unit can be used for rover and even for underground vehicles. Okay, so they have actually created a models that you can use in Gazebo world, and it is this thing. So we need to find that thing, but I think it will be there, and you can simulate that thing in ROS.
Okay, sir. Thank you.
Yeah. So Lavanya R
There
is.
is
Yeah. So when is it ideal to take up career in robotics? Okay. Ideal is okay. So one of my professors actually he's basically you can say a pioneer in motion planning. So he said that in upcoming 5 years, this current industry, I'm talking about, especially if you're talking robotics, I'm talking specifically about the autonomous robotics, self-driving cars, is going to be a hotspot. Upcoming 5 years is going to be hotspot. You'll see so many things, so many big changes going to be happening in autonomous robotics. Apart from it, there's so many things that is already being happening in this robotics world. So the question is not actually when it will be ideal for for you to start. The question actually you might ask when you should feel yourself ideal to contribute in this robotics world. If you're going to start now, you're most welcome, and you can contribute so many things to robotics world, because day by day it's increasing, it's developing, so many new things are coming. And if you have interest, enthusiast about robotics, I think you should start now. Why you want to delay this process? All right, I hope I've answered your questions correctly and up to your mark, Lamia. Yeah, you're most welcome. Okay, any other person that want to know, like, can we add something or not, Joss, apart from AI?
it's an open session now, guys. You can ask your questions, whatever
Yeah.
queries
And
or discussion you wish to proceed with.
okay then. So I'll just want to tell one more time about the course that we provide. We will be having a complete from, you can say it is a from basic, from zero understanding of ROS to you can say an intermediate or a high level understanding of ROS, and we'll be going through several stages. You just understanding the Linux system, then C++, because we are emphasizing more on C++. Okay, I just want to point out one more thing. Although ROS you can use ROS codes on Python, you can use ROS codes on Java and C++, but we are emphasizing more on C++ because for robotics, C++ is very important. And if you guys using Python for robotics application, I will suggest you guys switch to the C++ because you can do first of all, C++ is scripting language. So you can do that on C++. You can do any task very fast and very efficiently. So we'll be going through what is relevant to the current industry, So we will be doing C++. We will be teaching the core basic understanding the C++ till which you require, that is till classes, and then we will move ahead to understanding the concepts. We will first build the concepts and building blocks of ROS that we need to do, and then we will move ahead to this, and using throughout the course we will be actually at every point, at every task, we will be contributing something to our major project. That is, we will be building an indoor mobile robot that can autonomously navigate from one point to another. The slide which I had told you earlier, which I had shown you earlier, in which we were discussing about how a human moves from one point to another, and then they correlated back to an autonomous robot. So basically, we will be building that. We will be working on the simulation of making an autonomous mobile robot that can navigate from one point to another autonomously if and it will do all the steps. It will do the perception, it will do localization, it will create map, we will implement SLAM with it, we will do path planning with it, we will do motion planning with it, we will implement local planner, global planner, and we will be fusing all this together in building that. And after doing that, you will be able and you will be capable of understanding and the concepts of any robot. If you want to make an underwater autonomous robot, you can do that. If you want to work on autonomous drones, you can do that. If you want to, since you will be already working on UGVs, underground unmanned ground vehicles, you can work on that. So that will be a very, you can say, a kickstart project for entering this vast world of robotics. And I hope you guys will like. And I hope if there are no other questions, we should wind up the session. What do you say, Alchemy, about it?
Yes, thank you so much, Kashif, for such a good session. So, thank you guys, and our team will get back to you on the later part. Okay. So, thank you, Kashif. We can wind up the session. Thank you.
Okay. Thank you, ma'am.
Bye.
All right, guys. Good evening. Bye. I'm ending this session.